Hello guys, welcome to another session of Mate Mass. I hope you guys are doing good. One may ask, are we going to solve this problem again? The answer is yes, but it is not the same approach that we all know. This time is a different approach. One of a student at Amstead called Texan asked me how this problem can be solved with Lambert W function. Yeah, he was saying that he wanted to use the Lambert W function to solve this problem, and then he was finding it difficult, so he asked me to do a video on that. To show how Lambert W function can be used to solve this problem. We all know the previous approach that we used to solve this problem. We have solved it before. Okay, so the first approach that we used was the indices approach, whereby we equated the whole of this equation to 0 by bringing this one to this side, and then we use the indices approach to solve it. And then the other method was the logarithm with what absolute value approach. Yeah, you took absolute value of you take log of both sides, and then you take absolute value of this one, and then you are good to go. We all know that approach, but this time it is not that approach that we are going to use. This time I'm just going to show texting. Yeah, so in all is something that I thought that, oh well, it's a very good question, so well, I'll make everyone benefit from it. So I'm going to show you guys how to solve this problem using the Lambert W function approach. With this one, it's also using the same approach as logarithm, but when you take the log, when you raise somewhere, you have to apply the Lambert W function approach. Okay, so before we start solving this approach, we have to know something about Lambert W function. Okay, this one I will leave it to you. If you want theoretical something about Lambert W approach, we just go and then read something about it. But I'm just going to brief you what Lambert W function approach is. Mathematics is full of working the theoretical aspect. Normally we don't normally concentrate on that. So I'm just going to, in calculation aspect, I'm just going to brief you how the approach works, or how the approach is used. Okay, so first it's like, so let me write note. So it's like, now it's like this is how the approach is used. For you to be able to use the function perfectly, you have to get E, which we all know it is the base of natural log. We have logs and then natural logs, although they are all the same, but just the different form. When you take logarithm, the base is when the base is not written, we assume the base is 10. When you write natural log, the base is E. So to use this approach, you have to get E, and then you multiply the e by something, and then you raise the e by something. So in this case, you will get something times e to the power of something. Now, when you get something in that form, when you get a problem in that form, and you put it into the Lambert W function approach, then it will work out for you. So if what you are working on is not in the form of what I just said, the function won't work out for you. So to make the function applicable to what you are going to work on, you have to get something times e to the power something. What is multiplying the e and what is powering the e should be the same. That's how the Lambert W function approach works. So when you get it to be of that form and then you put it into the function, it will just give you your something back. Okay, you don't worry, I'm just going to illustrate something simple here for you to see. So let's assume we have 5. Let's assume the 5 is our something. Remember I said you need two things, probably 3 things, but the other two should be the same. The only difference will be the e. So let's assume we have 5. What else do we need? Another 5. And then what else do we need? E. Okay, so let's assume we have 5, and then we have e to the power 5, or we raise the e by powering it 5. Now we need 3 things: 5, 5, and then e. So this is our 5, but one of the 5 will power the e, so there's no need for us to write the e first before powering it. Just going to be some kind of waste of time. So when you are doing, you can write the e, and then later on you power it with the 5, and then later on you multiply it by the 5. Or you can also choose to do it 5e, and then later on power it towards the 5. Anyhow you do it, you're just going to get the same answer. Okay, so this is our 5, and then remember you said what is multiplying the e should be the same thing as what is powering the e. So here we power the e with 5, which is the same thing as the 5 here. Okay, so to make this one suit the Lambert W function approach, we have to multiply the whole of this by 5. Remember, something times e to the power something. So you multiply this one by 5. Now, this is what I was trying to depict for you guys. Something times e to the power something. What is multiplying here? You can see that what is multiplying the e is the same thing as what is powering the e. This 5 and this 5 are the same. They are not different. What is here is the same thing as what is here. Now, when you have something like this, and then you put it into the Lambert W function approach, it will just give you a 5 back. So someone may ask, so when do we use this approach? So we use this approach when we have something of this nature and we want to get the something back. I hope you are not confused. So we use the approach when you have something like this and it is in the form of something times e to the power something, and we want to get the something back, not the e, we want to get the something back. Okay, so to get the something back, we just use the Lambert W function approach. Alright, if you want to a proof of how the approach came by and the other stuff, just do the further readings later on. Maybe when I find time, maybe I'll just take you through later on. Okay, alright, so to get our something back here, we're just going to use the Lambert W function, because now it suits the function or the approach. Okay, so the short form of the Lambert W function is capital W, not small w, capital W. Okay, so I'm just going to take, normally we say W, so we are going to take W of both sides. Normally when it's in equation form, we take w of both sides, but here you're just going to take w of this, and after taking w of this, you're just going to get what? Our 5 back. Okay, so now let's take w. This is how the function works. So now because this one suits the function, when you put into the function, this is how it's going to look like. Now because it suits it, you're just going to get what? Our something back. So what is our something here? 5, 5, 5. So just put it in your head that anything at all in this form, what is here is the same thing as what is here, and we're having e here. When you put it into the Lambert W function, don't forget about how you're going to just put it in your head that what you are going to get is what is here or what is here. Okay, so you are just going to get what? 5 back. Now we have our 5 what? Back. That's how the approach works. So if what is here is p, and then let's say what is here is also p, we just get our p back. Just forget about the e. The e here, I will not go when I go there to confuse some of us, so I will not go there. So just what I want you to get is that when you have it in this form and you apply the Lambert W function, you just get your something back, and the something here is what is multiplying the e and what is powering the e, which is in this case what should be the same. All right, good. So guys, this is the approach that we are going to use. So at the end of the day, we are just going to manage, we don't know how, but we're just going to find a way to write this equation here to look like this one. Then we will apply this function to get we are having 2x, one is here and then another one is here. So we are just going to find a means to rewrite this and then this in this form so that we can get one of the x back. Okay, all right, let's get into the video. X squared is equal to 16 raised to the power x. We are not using the previous approach, so don't rush. If you rush, you might get it wrong. So just take your time, and you see that it's very, very simple. It's similar to the logarithm with absolute value approach. Yeah, it's similar to that, but the only difference is the Lambert W function. Okay, don't worry. So x squared is equal to 16 raised to the power x. What are we going to do here? What we are going to do here is we're just going to take natural log, not logarithm, natural log of both sides. The motive of using natural log is that the functions uses e. So if we take logarithm, there is no way we are going to get e. So in order to get e, we have to use logarithm, which use a base of e. That is a natural log. That is why we are using natural log, so that we can get e, or we can get e in our solution to make the function applicable. All right, so let's take natural log of both sides. So let me write that one for you. Take natural log of both sides. All right, now let's take the natural log of both sides. The short form of natural log is the ln. Yeah, you can say ln or natural log. So natural log of x squared is equal to natural log of 16 raised to the power x. And we all know from the laws of logarithm, these two here can be written at the back here, and then this x here can also be written at the back here, right? That's what we are going to do next. So let's do that. All right, well, here we're having 2 multiplied by natural log of x is equal to x times natural log of 16. What are we going to do? Now take note, here we are going to take absolute value of x. But mind you, when you are taking the absolute value of x, please take into consideration the function involved. Here Though this one too, this one is a number, and then also this one is also a number, because this one is in front of this, it makes this one what? The function. So the focus of taking the absolute value should be on what? This one, not this x. Well, maybe you can go ahead and then take absolute value of what? This, and then this at the same time, and at the end of the day, maybe, well, maybe you can still find your way through, or maybe it can still work out for you. You can do it like that. But if you don't want to take both sides, if you don't want to take the absolute value of this and this, mind you, if you want to take one of them, what you have to take is what? The natural log of what? X, and not what? The x. Okay, you can take the absolute value of natural log of x and also x, or you take the natural log of what? You take the absolute value of what? Natural log of what? X. Okay, but well, let's go by this way. Let's go by this way. Let's take the absolute value of what? This one, because here the natural log of x here can be assumed to be the function. Okay, good. So if you take absolute value of this, it might be something else. Though you might get your way through, but you struggle a little bit. Okay, so to avoid struggling or fumbling and other stuff, you're just going to take the absolute value of what? Natural log of what? X. Natural log of what? X, and then we just forget about this x. No, when we are, as we are moving on, whatever we do to this will one way or the other affect this. So we will just focus on this one. So the absolute value that we are going to take will be on what? This one, and not this. Okay, good. Good. So 2 times natural log absolute value of what? X. The absolute value here means that this one, in our previous video, I did, because we use the absolute value throughout the calculations, I did a lot of explanations on that. So here I'm not going to waste much time here. I'm just going to say something small, and then we just move on, because if you want, we already know, or if you want more about absolute values concerned about this workings, go find that previous video, and then I also do just say by leaving that video in the comment section for you guys, so that maybe if you have forgotten, you can click on it and then watch, or if you didn't see it, or if you didn't get it to watch, you can use the opportunity to watch it. Okay, so here the absolute value simply means that we don't know at the end of the day what value of s are we going to get, positive or negative. Okay, when you use calculator to punch this equation, s is going to be minus 0.5, but let's assume we are not using calculator, we are just using our hairs. Okay, I hope you are getting me. Sure. So if we base on what the calculator will give us as what? The minus 0.5, then we will say the answer is what? Negative. So there's no need for the absolute value. But we are assuming we don't know the answer, so we have to take absolute value of what? X, which is what? Either be positive or what? Negative. Okay, good. Now, what we are going to do here is that we need to get all x, or no matter what the s is having, or blah blah, we need to get all x on one side, all x on one side, and then all numbers on what? One side. Now mind you, like I said, this is what? The function. Here, natural log of 16 is what? A number. Natural log of 16 is what? A number, because it has a numerical value when you punch it on the calculator. But natural log of x is, we don't know unless we find what? A value. So it becomes what? A function like y is equal to blah 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 blah, unless we use the blah 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 to do something before we get the actual value of what? X. So y, the value of y depends on the other expression given. Okay, so we're just going to group those having x on the other side and those having numbers on the other side. And this is how we are going to do it. You can do it in bit, but here I'm not going to do it in bit. I'm just going to make it once because we have been solving this problem, and we know how, critically, or how the approach, goes by. So then what I'm going to do here, it won't be something, or it's not something new to all of us. Okay, good. So what we are going to do here is that we want this x to this side, and then we want this one to this side. So how are we going to do that? So since we want this one to this side, when we bring this one to this side, because we will divide, it will be whole denominator here. And when we also bring this one to this side, because it will be, this will also be all in the form of denominator, it will divide. That one also will be in the form of a denominator, right? So what you are going to do here is that we're just going to multiply through by 1 over 2x. 1 over 2x. Okay, now let's multiply through by 1 over 2x. Now we multiply through by 1 over 2x. I think it will help us get each and every one of them in their position as we all want. Okay, all right. So here this 2 will cancel out with these 2, and to be left with what? X. That is 1 over x. Now you see what I was saying, because it will divide. When we divide the whole of this by x, it's going to get the same thing as this. Okay, and then here this x will cancel out with this x, and then you see these 2, it has come here, and when it came here, it becomes what? Denominator, right? Good. So this will cancel out, it will be left with what? 1 over 2. All right. Now this is what we have gotten so far. Please, it's not difficult, it's very simple. Okay, now this is what we have gotten so far. Still, we don't know the x, but remember we said we need to group the x on one side and then numbers on the other side. The motive is we are trying to rewrite it to suit what? The Lambert W function approach. Okay, good. So here what we are going to do here is that 1 over x here can also be written as what? X raised to the power minus 1. And then this 1 over 2 here can also be written as 2 raised to the power minus 1. Or we can bring it to this side, because it's a number here. If this side appears to have any value here, any number here, and then we would maybe, or if this one also is in the form of something like this, we will not write it to raise to the power something, but we just bring it to this side, and then we just square. Here this one is, we don't, assuming if we know the value of this, probably it will be in the form of what? Root. So we just bring it and then we square this, whatever is here, and we are good to go. Okay, I'm saying this one because of what we are going to do to this. Okay, we are just going to bring this one to this side, and when we bring it to this side, just going to be square root of 16, and that will give us what? 4, or 16 raised to the power 2. Using indices, you're just going to go the same answer. All right, good. Now we will write this one as x raised to the power minus 1, and then we will write this one as 4 raised to the power 2 times 1 out of 2. Why? Because it's the same thing as square root of 16, which is the same thing as 4 raised to the power 2 times 1 out of 2. The value of the square root is what? This half. Okay, all right. Please, if you have any question concerning about the individual steps, make sure you leave it in the comment section, and then I will make sure I will answer you. Please, if you are enjoying the video, please kindly make sure you subscribe, like, and then give your comment, and share it to your friends and invite them to also come and enjoy. Okay, good. Thanks for doing that. Now let's continue. All right. Okay, this one, if you apply the laws of indices, that is the negative index law of indices, um, to write a fraction in a form of power and a base, you just use the negative index form. The negative index law for it is, that is, yeah, you all know that. I'm not going to say that for you. And then this one here is the same thing as what this. At the end of the square root of 4 will give us what? Square root of 16 will give us what? 4. Or this times this will give us what? The same thing as what? 4. So this will cancel out with this and to be left with what? 4. So this one is equal to natural log of what? 4. Good. Still, we haven't gotten the value of x, but at least you could see that we are doing something good. The way it was and where we have reached and where we are going, you can see that what we are trying to do will work out for us, as you are seeing here. But the question here is how? Because looking at this one, there is no way we are going to get what? E, right? Yes, there is no way. That E, are we going to borrow it, or somebody is going to give it to us, or how are we going to do it? Well, the E, you don't just bring in the E from anywhere. You don't just bring the E from what? Anywhere, but you make sure how you use the E at the end of the day. When you simplify that, when you simplify it, you should get what? The original state back. I hope you are getting me. What I'm trying to say is that if we use the E to rewrite this one to suit the function, at the end of the day, when we simplify what we use the E to rewrite, we should get this one back. So actually, we don't just get the E from somewhere, but we do something to one of these to get the E. Remember, I said initially that is the reason why we are using what? Natural log. Okay? Because we don't want to just get the E from anywhere, or we don't want to just introduce the E just like that and then say it has suited the function. That is why we are using what? Natural log, and not what? Logarithm. Okay, guys? Good. Now, what are we going to do here? Well, here when you reach here, when you point this on your calculator, the calculator will give you answer as what? Minus 0.5. But the question is, here we are having two things. And what are these two things? Remember, we are having, if it is not the absolute value, then everything could have been sorting from here. If it is not the absolute value of this x, but if this x appears to be x just like this one, then this this one could have been very simple for us to solve. But because of this absolute value, I'm just going to work this one in two ways. That is, first, we will assume, remember I said that forget about what the calculator will give you when you punch the original equation, which is what? Minus 0.5. Bearing in mind that x is what? Negative. Now we don't know, we are just what? Working it out. We are not using calculus. Okay, good. So first we are going to assume that we are going to assume that x is what? Positive. Then we will work on it to see if we will get the value for what? X. And then also we will assume that x is what? Negative. And then we also work on it to see what we are going to get. But mind you, at the end of the day, the answer that you get when you assume x to be positive and also when you assume x to be negative, it should be the same. If you get any of them to be different, it means you are wrong. It means you missed a particular step, or you didn't treat a particular step very well. So you just have to be careful in treating the positive and the negative cases. Okay, so here what we are going to do here is that we are just going to split it into two. The first one will be, we will assume x is what? Positive. That is when x is greater than 0. Any number greater than 0 is positive. and any number less than 0 is what? Negative. When you draw the axis, below the 0 is what? Negative figures. Up the 0 is what? Positive what? Figures. And also both left, and then you go left, you see it's negative, right is what? Positive. But in this case we want the up and down. Okay, but still, you see they are on the 0 is in the middle. All right, so first let's going to assume x is what? Positive. When x is positive, you don't need the absolute value, and also when x is negative, you don't need the absolute value. All right, good. So first let's take x is equal to when x is positive, that is case 1. When x is greater than 0, greater than 0 means what? Is positive. Is what? Positive. Good. Now let's find out when x is positive what we are going to get. Now when x is positive, remember I said we don't need the absolute value, or we don't need what? The absolute value of x. We only need what? X. We only need what? X. Good. Now, well, x raised to the power minus 1 times natural log of x equal to natural log of what? 4. What we are going to do here is that, remember I said we have to do something to bring in the e. We will not just introduce it just like that. If we introduce it just like that, it will be maybe this times e times this, which at the end of the day won't be the same thing. Which at the end of the day, what we are going to get multiplying the e will not be the same thing as what is what? Powering the e. So to make the what is multiplying the e and what is powering it the same, we have to find a means of introducing that e, so that at the end of the day, what is powering and what is multiplying will be the same. I hope you're not confused. So the question is, how are we going to do it? Good. Remember when we have log to a number to the same base, will give you what? 1. So log 10 to the base of 10 is equal to 1. The same way, natural log of e to the base of e is equal to what? 1. So if you are having natural log of maybe 5 to the base of what? E. What are we going to get? We're just going to get our 5 back. Why? Because the natural log is already having a base of e, and here in the case I'm having another base of e, or maybe the natural log of what? 5e. No, sorry, not 5e, but what I'm trying to say here is that for you to get in the e, we have to use the natural log a property of what? Logarithm. That's what I'm trying to say. Sorry for what I said earlier on. We have to use a property of what? Logarithm. That is a number raised to a log of a particular number with the same what? With the same what? Base. The same base here simply means the number which has been raised to that logarithm number, the base of that logarithm is the same thing as what? That number which has been raised to that logarithm. So at the end of the day, that the base of that logarithm and that original base will just cancel out, and it will give you what? The number in the logarithm or value or back. Are you confused? Don't just get confused. Let me say it again. What I'm trying to say is that let me use variables. If you have something like a, or let's say b, raised to the power log of, let's say, c to the base of what? B, the answer is equal to c. Why? Because the base of the logarithm and the variable which is what b, which has been raised to, are the same. And anytime the base of a particular power becomes the same, the base of a particular power becomes the same, it just cancels out and you just get your what, your answer. So what I'm trying to say here is that when we have something like e raised to the power natural log of, let's say, c, it's just going to give us what, c, because the base of natural log is what, e, and already we are having another e, so that e and the base of natural log will just cancel out and you just get what, the c, and that is all. I hope you are okay. So what we are going to do here is that this one here, this one here, we are having x raised to the power minus 1. Good. In order to get or rewrite this one so that we can get it back if we want, we have to use natural log plus e, which is e raised to the power natural log of x raised to the power minus 1. The e and the base of the natural log is also e, so at the end of the day, the base of the natural log and that e will cancel out and it will just give us this one back. Let me put it down for you and you see what I'm trying to tell you. So this one, just going to use e, e raised to the power natural log of x raised to the power minus 1. At the end of the day, when you do the cancellation, you're just going to get this one whole back. That's all what I'm trying to say, and it's one of the property of what, logarithm. Good. So this is what I'm trying to tell you guys. Something times e to the power something, though we are getting it, but it's still not something times e to the power something. What is here is not the same thing as what is here because of this one here. Okay, no, what I'm trying to tell you is that the base of this natural log is what, e, and here is the case we are having another base here. In a form of indices, this one is in the form of what, indices, that is, this one is the base and then this one is what, a power, and now this power is in the form of logarithm, and every logarithm has a number and a base. So in this case, the base of that logarithm and this base of that indices will cancel out, and that number of the number of that logarithm will be written as what, the answer. So in this case, the number here is what, let's assume the number here is what, the x raised to the power minus 1. What is the base of the indices? That is e. And what is the base of logarithm, or the base of the power? The power here is what, the natural log, and the base is what, e. So that e and this e will what, cancel out, and what will be left with what, this one, which is the same thing as what, this. So you see, we just used what, the property of logarithm to bring in what, or to introduce in what, or to introduce what, the e into the equation. So at the end of the day, if you want the e to be off from the equation, we just do the cancellation. Here we are going to do the cancellation because we need the e. I hope you are getting me. Sure, good. Now let's move on. Now remember, it's something times e to the power something, but this one and this one are not the same because of this minus 1 here. So what we are going to do here is that we're just going to bring this one to this side. Okay, good. Now is it the same? All right, here still is not the same, still is not the same. So what we are going to do here is that, how can we make this and this to be the same? This here is the same thing as all this here, but here is negative, but here is positive. So we're just going to multiply through by minus 1. Multiply through by minus what, 1. Now when you multiply through by minus 1, this one will be negative and it will be the same thing as what, this. Now mind you, the whole of this one is what, one thing. Don't think that when you multiply through by minus 1 to affect this at the same time, you're just going to affect this. No, when it affects this, it affects the whole of this, but this one affecting this doesn't affect this one here. I hope you are getting me. Good. So to make this one affect everything here, we're just going to make this one negative. And because it's an equation, what has to be done here will also be done here. All right. Good. Now we all can see that this one suits the function perfectly. Why? Because what is here is the same thing as what is here. Just forget about this one. There are some cases you will not be able to rewrite this number side in any way to look like this. So in that case, if you're able to write the variable aspect to look like this, we just forget about the figure aspect. There are calculators which we can manipulate that one, and then they to just give you the value. So that one we don't normally worry about. The most important thing is to get one of the something back. Okay, so here we just take W of both sides. We take W of this and also take W of this, since it suits the approach. So take Lambert W function of both sides, since it's an equation. So let's take W of good. Now here, remember we said that when it's something times e to the power something, and you apply the approach, you just get your something back. So what is our something here? Our something here is just what? Sorry, minus natural log of what? X. Okay, so this one we're just going to get minus natural log of what? X, and it's equal to this one. Now the question, you are seeing something here. I hope some of you is going to put it in the comment section why they are seeing this, but I prefer you watch it to the very end before you you ask why, because as you can see, I'm just going to talk about it, but I'm just going to start from here. W of minus ln2, when you punch the original equation on the calculator, the answer is minus 0.5. Good. So is x is equal to minus 0.5, but not natural log of x is equal to that minus 0.5. So the question is, we managed to rewrite the S category to suit the approach to get something back. Here, can we also rewrite this one to suit the approach to get something back, so that we can get the numerical value? The answer is sometimes it can be yes, sometimes it can be no, but in this case, in this video, it's yes. But I prefer explaining both of them, because most of the time it is not possible to get the other aspects, which is what the numerical aspect will to be to suit the approach. If you get it to suit the approach, then you get your something back from it. But most of the times it is not possible. So if it is not possible, we'll just leave it as it is. So assuming this one is not possible, what is here will be the same thing as what is here. And at the end of the day, you just multiply both sides by minus 1, and then you just take e of both sides, and whatever you get will be the value for x, and that's all. There are calculators, the advanced calculator that can punch whatever you're going to get for the value of whatever you're going to get for x, and to be able to give you the numerical value. Okay, but here in this video, it is possible that we can rewrite this one in this form, so that this W can give us one of either this or this back. Okay, so how are we going to do that? And that is what you are seeing here. Minus natural log of 4. Now mind you, 2 times 2 is 4. Minus 2 times 2 is minus 4. But minus 2 times minus 2 is the same thing as what? 4. So in this case, 2 times 2 is equal to minus 2 times minus 2. Then, using indices, if 2 times 2 is equal to 2 raised to the power 2, then minus 2 times minus 2 is also equal to minus 2 raised to the power 2, which at the end of the day is the same thing as what? This 4 here. Are you getting me? Yeah, sure. So minus 2 raised to the power 2 is the same thing as what? 4. So here we will write, the motive is we are just rewriting it to suit the approach so that we will get something what back, or so that this W can be what taken off. Okay, and that is what you are seeing here. So here we will bring these two to this side so that at the end of the day, when we rewrite the two, we will just, whatever will be here will be the same thing as whatever will also be here. Okay, good. Good. So here we're having minus 2 times natural log of what? Minus 2. You know, it's similar to the other one, right? Where it was x raised to the power minus 1 times blah 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 blah. Yeah, good. So here, how can we rewrite this one to suit the approach? That is, we will just introduce the e by rewriting this minus 2, which is e raised to the power natural log of what? Minus 2. Someone may ask, the other one it was to the power minus 1, but this one is minus 2, not to the power minus 1. Okay, so make sure you don't confuse yourself with it. Good. So this one can be written as natural log of minus 2 times e raised to the power natural log of what? Minus 2. Alright, here, yes, it suits the approach. This one is similar, not the same, is similar to this one here. So it suits what? The approach. And anytime it suits the approach, we will get our something back. So what is the something here? The something here is what? Natural log of what? Minus 2. Okay, so you're going to get minus natural log of x equal to natural log of what? Minus 2. Good, good, good. You see, we are doing something good, right? Yeah, I'm just going to get the 0.5 as the calculator will tell you. Alright, so what's next? Well, we are just going to calculate for the value of what? X, and it's very simple. But yet it's not yet equal. It's not yet equal because though there's a variable here, but it can be equal by making this natural log what? Negative, because when you come to the left hand side, the natural log is what? Negative. So when the natural log on both sides of the equation becomes the same, their numbers too are also what? The same. Okay, good. So in this case, what are you going to do? Well, there are two ways. You can multiply both sides by minus x, because we are after this what? Minus 1, because we are after this what? X. So when you multiply through by minus 1, this one will be positive and this one will be negative. And x will be equal to minus natural log of what? Minus 2. At the end of the day, that minus here, we will bring it to this side, it will be natural log of what? Minus 2 to the power minus 1. And since the natural log has become the same, we just say x equal to minus 2 to the power minus 1, and which is the same as what? The 0.5. Or you can also rewrite this one so that the number, the natural log, and also the number will be the same. I mean equality. How are you going to do that? Remember, when we bring a negative sign here, this original one here is what? The natural log is what? Positive, it's not negative. But when we make it negative, without doing anything to this one, it won't work out for us. So what you're going to do here is that you're just going to make the natural log negative, and also make minus 2 negative. But in this case, we will make the power of minus 2 what? Negative, so that at the end of the day we will get what? The natural log of what? Minus 2 back. Minus, and then we have another minus here, same thing as what? This one, because when you bring this minus sign here, it just becomes what? Positive. Alright, good. As you can see, when we bring this one to this side, it becomes what? Positive. Alright, now since this one is the same thing as this, we assume that this one too is the same thing as what? This one. So by comparison, or by equating component, x is equal to this one, that is minus 2 raised to the power minus 1. By negative index law of indices, x is equal to minus 1 out of 2, minus 1 out of 2, or x is equal to minus 0.5. You see, with that calculator, we have gotten the minus 0.5. The minus 0.5 is all because of the Lambert W function approach. You see, looking at that particular problem, you might think it's very difficult. How are you going to work this minus 0.5 out without using graph? When you use graph, you get it. But what if I don't want to use graph? How are you going to work it? Do the workings to get your what? That 0.5. How did the calculator do it? So we can see that this is how the calculator did it. Or maybe the calculator used the graphical approach, or anyhow, well, we have, all we care is what? Getting our answer at the end of the day, and that is what we have what? Gotten. Alright, now the positive aspect has given us x is equal to minus 0.5. Now let's look at what? The negative aspect, that is when x is what? Less than 0. That is when x is what? Negative. So case 2, when x is less than 0, meaning x is what? Negative. Alright, here I choose to repeat what we had there on the other section, because of what we are going to do, because of what? The negative of what? X. Okay, now remember, we treated the first aspect as what? Positive. So the next aspect is going to be what? Negative. Okay, but this negative here is just affecting this x here, because that is the only x that we took the absolute value of. So that is the only x we will consider as positive or negative. Good. So what are you going to do? Remember, everything that you have to do, make sure since we are using the Lambert W function, make sure that something and something will always be the same. So first, we have to make this x here and then this x here be the same. How? Either we make this one positive, or we make this one negative. But it is more easier, or much easier, to make this one negative than to make this one positive. Any question? Easy? Yeah, sure. Let's move on. Let's move on. All right. So you are going to multiply through by minus 1. When you multiply through by minus 1, this x will become negative. And on the day when you apply when we introduce in the e, you can see that the natural log will just take the whole of this one to be negative, and it will be the same thing as this one. All right. So multiply through by minus 1. Now when you multiply 2 by minus 1, this is what you are going to get. Alright. Now let's introduce in our e. and that is e raised to the power natural log of minus x raised to the power of x multiplied by this one. Good, good. But still, it's not yet the same. It's not yet the same. Who can tell me why is it not the same? Who can tell me? Yeah, leave your answer in the comment section for me before I proceed. Alright, let's move on. Somebody had it correct. What we are going to do here is that, like what you just sent, that is, we're just going to break this one to this side, and then we just multiply through by another negative, so that what is here and then what is here will be what the same. Okay, so we will just bring this one to this side. Good. So what is the next step? Multiply through by minus 1. You can avoid this multiply through by minus 1 just to, though have, say it, but I have to also write it for you so that it will always remind you. Maybe as at the time I was saying it, your attention was somewhere. So when you see it, then you know what to do, or you know why we had that answer for the next step. Good. Now, as you can see, this one and then this one are the same. Now, let me say something here. Whilst you are trying to rewrite this one, at the same time, you can also think of how you can rewrite the number aspect. If you think the number aspect is not possible, just forget it and then just concentrate on what the other side. That is the variable what or the function what aspect. Okay, so the other side you were able to rewrite what the natural log of what 4, right? So here in yours, when you are working yours, don't waste time of getting something from this one and later on come and get something from this one, because you already know how you can rewrite or something like this. So just a matter of just splitting it and just rewriting it as you are all rewriting this one. Just write both of them at the same time, then you're just good to go. Okay, good. Here I just did it this way so that I can say something about how this one or maybe this one can be done, just to avoid being confused. Okay, so now let's take W function of both sides. Alright, so let's take good. Here, what is here is same thing as what is here, so you get something back. So the something here is minus natural log of what minus x, but when you come here there is no something, so this w will still be on this one until we get something times e to the power something. Good. As we did for the other part, this 4 here can also be written as 2 raised to the power 2, and 2 raised to the power 2, applying the law of logarithm, can also be written as what 2 times natural log of 2. The motive is what? To get rid of this w, or to suit the function. When I say to get rid of this w, don't get yourself confused, because getting rid of this w means you are making it suit the function in order to get something back. Sure. So here we're just going to rewrite this one, that is natural log of what e to the power natural log of what 2, which at the end of the day will be the same thing as what this. Alright, what is here is the same thing as what is here, so we will just get our something back, which is what? Natural log of what? 2, right? So this one will be equal to natural log of what? 2. Good, good, good. So what are we gonna do? Well, you can use how we solve the other section. How we did it to get our 0.5. You can use that approach, but here maybe, well, you can use that approach as well, but here maybe I'm not going to use that approach as well. So just going to multiply through by -1. The other part we should have used the multiply through by -1, then take E of both sides and move on, but we didn't do that. So here we're just going to multiply through by -1, and that will give us this one is equal to minus natural log of 2. All right, these two will come here, and you get this one is equal to 9. So here we're just going to take E of both sides. We take E of both sides, or this is equal to this, since the natural logs, both natural logs are all positive. So you can say by comparison, this is equal to this, and that's all. You are good to go. All right, good. So let's take E of both sides. Good. So here you're just going to get x, and then you're gonna get this one. So minus x is equal to 2 raised to the power -1. And then we multiply both sides by -1. So x is equal to -half, or x equal to minus 0.5, minus 0.5. So you can see, you see, at the end of the day, both the positive and the negative aspect has given us what? The same answer. If this one appears to be what? A different answer, it will have making our hot approach wrong. So make sure at the end of the day, when you take something to be in absolute value form, make sure at the end of the day, the answer that you get for both of them should be the same. Alright, now we have gotten x is equal to minus 0.5, but let's prove it if it is true. We're just going to put minus 0.5 into the equation to confirm if it is what? True. Okay, so proof. X squared is equal to 16 raised to the power x. Good. What is the value of x? That is minus 0.5. So we put minus 0.5 here and also minus 0.5 here. Good. 16 is the same as 2 raised to the power 4. Then we multiply it by minus 0.5. And also minus 0.5 raised to the power 2, or minus 0.5 what? Squared. And that will give us what? 0.25. And it's equal to, minus 0.5 is the same as minus 1 out of 2. And 1 out of 2 times this will give us what? Minus 2. So minus 0.5 is equal to 1 over 4. From the negative index law of indices, this one is equal to this. So therefore, either we change this one to fraction or we change this one to decimals. But I prefer changing this one to decimals. Okay. So at 0.25 is equal to 0.25. So you see, at the end of the day, after putting in x equals to 0 minus 0.5, we had both left and right hand side to be the same, which means the value of x from the equation is, the value of x from this equation is what? Minus 0.5. Minus 0.5. Guys, the Lambert W Function approach is very cool. It's very cool. Though the indices approach is very cool. Yeah, the other one is also very cool. But you don't worry, I will leave a link to the indices approach and the logarithm with ABS in the description section of this video, so that if you have forgotten or maybe you didn't get chance to watch that video, you can go click on it and then you enjoy yourself. Okay, so any questions so far, or what you guys think? Is it pretty cool, or what you guys think? All right, make sure whatever you are thinking, or if you are having any question, make sure you leave it in the comment section for me. Okay, good. All right, so guys, that's it for you. Texting Amstead, I'm expecting more from you. Make sure you invite more of your friends to come and also enjoy from this video. And if you have any question concerning this video, make sure you let me know. All right, so that's it, guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching. I will see you in another video. Bye.